Today we will explain Docker without heavy technical language. The main idea is simple. Docker helps package an application together with what it needs to run. That makes the application easier to move, launch, and update. When we say application, it is easy to imagine one file or one launch button. In real life, an application needs an environment, a programming language, libraries, settings, and sometimes a database or web server. Docker helps describe and package that environment. A very common situation is this. The project works on the developer's laptop, but fails on another computer or VPS. Often the problem is not the code itself. The problem is that the environment is different. The simplest analogy is a box with a ready-to-use kit. Inside it are the application and everything it needs. The user does not assemble all the parts by hand. They launch the prepared environment. A container is a running copy of an application inside a prepared environment. It is separated from the main system and from other containers. That makes it easier to run several services neatly on one VPS. An image is not the running application. It is the template that describes what the container should contain. When we start an image, Docker creates a container from it. It is important not to confuse Docker and a VPS. A VPS is a remote computer running in a data center. Docker is a tool inside a computer or VPS that helps run applications in containers. Docker becomes especially useful when a project needs to live outside one person's laptop. For example, a website needs to move to a VPS, a Telegram bot needs to run around the clock, or a database needs to sit next to an app but stay separate. Docker appears in many practical tasks. Launching a website, running a database, deploying an internal dashboard, or installing a ready-made service. For the user, the benefit is that launch often becomes one clear command. The main benefits of Docker are repeatability and cleanliness. You do not have to fill the main system with many different dependencies. The project describes what it needs and starts more predictably. Without Docker, different projects may require different versions of the same tool. That quickly becomes confusing. Containers help keep projects separate and make it easier to remove what is no longer needed. Docker is not magic. You need to understand a few new concepts and be careful with data. If data is stored only inside a container, it may disappear when the container is recreated. It is also important not to expose unnecessary ports. The most important practical rule is this. A container can be deleted and recreated. That is why important data should be stored separately, for example, in a volume. This is especially important for databases, user files, and service settings. For a user, the simplest scenario looks like this. Install Docker, open the project folder, run Docker Compose upd, and then open the result in a browser. Compose reads the project description and starts the needed containers. A Docker file is like a build recipe. For example, we can take a small web server image and copy our web page into it. Then Docker understands how to build the image for the website. Docker Compose is useful when it is easier to describe the whole project at once. Even if there is only one service, a Compose file makes launch clear. In larger projects, it can include a website, database, cache, and other parts. For a demo, we can use a very simple web page. The Docker file says that we take a small web server and copy index.html into it. The Docker compose.yml file says that the site should open on port 8080. In the demo, the user starts the project with one command, opens localhost 8080, and sees the page. When the demo is finished, the container can be stopped with Docker Compose down. AI is useful not only for writing code, but also for packaging a project. A good prompt asks for a Docker file, dockercompose.yml, a launch port, and a short read. Then the result is closer to a project you can actually run. The summary is simple. Docker helps package an application and its environment. A container is the running environment, an image is the template, and Compose is a convenient way to start the project. The goal is not to memorize every command, but to understand where Docker saves time.